flat up here in the video. Alright. On this piece of paper that you have, up at the top, are sum and difference identities. Right? These can be used to find exact values of sine, cosine, and tangents of angles other than the ones that we've already memorized. Okay, so we know all of the angles around the unit circle, right? Which in terms of degrees would be 30, 45, 60, 90, right? And then all the multiples of 30 and all the multiples of 45 all the way around. Same with in terms of radians, right? 0, pi over 6, pi over 4, pi over 3, pi over 2, and then again, all those multiples all the way around. So, we can use these sum and difference identities to find exact values of more angles. In this first example, they ask us to find the exact value of cosine of pi over 12. Well, if you look at this formula on your paper, it's cosine of, or we've got two different formulas for cosine, right? Cosine of A plus B and cosine of A minus B on your paper. So what we want to think about is how can I add or subtract two angles for which I know the values of to get pi over 12. Okay, and if you want to convert to degrees, that's okay. Right? If you're more comfortable working in degrees, you can always change this to degrees. Okay, but a couple of angles that I know, if I subtract them, pi over 3 minus pi over 12. Okay, again, if instead of radians, you want to think about degrees. Okay, if I convert pi over 12 to degrees, pi over 12 times 180 over pi, pi's cancel, and 180 divided by 12 is 15. So we can think about this as 15 degrees instead of 15 degrees. So I want to think about two angles that I know on the unit circle that can add or subtract to get 15. Okay? Well, I know 60 and 45, and I know the values of sine and cosine of those angles. So I can say, well, 15 is the same as 60 minus 45. In terms of radians, though, that would be pi over 12 is equal to pi over 3 minus pi over 4. So we can use this formula to calculate the exact value of cosine of 15 degrees, or pi over 12. So our difference formula for cosine is cosine, I'll just write out the whole thing first, generically. Cosine of A minus B is equal to cosine of A times cosine of B minus sine of A times sine of B. So in this case, our A and our B are 60 and 45, because we're saying cosine of 15 degrees is the same as cosine of 60 minus 45. So I'm saying cosine of 15 is the same as cosine of 60 minus 45. So 60 and 45 are my A and B. So this is going to be cosine of 60 degrees times cosine of 45 degrees minus sine of 60 degrees times sine of 45 degrees. Right?
Does it matter whether or not we do it in grade?
No, that does not matter. Right? So if, no problem, if you're given radians, you can convert it to degrees, or you can just work in radians. So now, the reason that we do that is I know all four of these exact values. Okay? We're thinking in terms of the unit circle. So in terms of the unit circle, what is the cosine of 60 degrees? what's the cosine of 60 degrees? You didn't sound too sure.
Yeah, no. Yes, it's 1 half.
It's 1/2. Yeah. Okay. So this is another big reason why we need to have those values on the unit circle memorized. Okay.
Yeah.
Right? So that we can find an exact value like this. What's the cosine of 45? Square root of 2 over 2. What's the sine of 60? 3 over 2. And the sine of 45? 2 over 2. So now I can simplify this a little bit. 1 times the square root of 2 times 2 or over 2 times 2 is going to be square root of 2 over 4. Right, when we're multiplying fractions, we multiply the numerator and denominator. Then over here, square root of 3 times the square root of 2 is just square root of 6 over 2 times 2. And finally, I can combine those into one fraction. I already have common denominators. And so I can just write this as the square root of 2 minus the square root of 6 all over 4. So the exact value of the cosine of 15 degrees, or cosine of pi over 12, is the square root of 2 minus the square root of 6 over 4. Okay. Questions? All right, let's try another one. About how about the sine of 75 degrees? Okay. So the first thing that we want to think about is finding two angles that we already know on the unit circle that can either add or subtract to get us 75. So what two angles? And there's not just one correct answer. There are multiple ways to add or subtract numbers on the unit circle that we know to get 75. 15 isn't one of the ones that we know.
I'm ready to drop.
So we know 0, 30, 45, 60, 90. Yeah.
There's no way to actually. So
Yeah.
ready?
Let's go.
You said Denver was the state.
So since this is I wrote this in terms of degrees, we could split this up into 45 plus 30. Okay, 75 would be the same as 45 plus 30. Or, as Sam told us, if we wanted to think about this in terms of radians, that would be pi over 4 plus pi over 6. Right? So now, we can use our formula. So I'm using the sum formula for sine, which on your paper is the first one, right? We have sine of A plus B. So this is going to be sine of my first angle times cosine of my second angle plus cosine of the first angle times sine of the second angle. And now, because we have the unit circle memorized,
Yeah, we do. 15's on.
17 is not one of the ones we have memorized. We can get all four of these values. So sine of 45, square root of 2 over 2. Cosine of 30, the x value at 30 degrees is square root of 3 over 2. Cosine of 45, square root of 2 over 2. And the sine of 30 is 1/2. So from here we just simplify. So here we'll have square root of 6 over 4. Here we'll have square root of 2 over 4. And adding those together, just get the square root of 6 plus the square root of 2 over 4. Because it's all memorization. Like, if you have the unit circle memorized and this formula memorized, it's a piece of cake. It's not, there's no real thinking involved. It's just memorization, right? Which is why this one isn't my favorite section. I like the last one better.
You like a tour.
Well, that's true too.
I'm just worried about the last section. Like, I literally just don't get it. Yeah, this is easy. See, I don't want to see it. Oh yeah, I've seen it. Alright.
Alright, let's try a tangent one here. How about, let me come up with a good one.
Did you?
Mr. Batch, I can this guy.
Sorry.
Sorry. Can I push it?
You can move it a little bit.
I got it. I don't know anybody.
Alright,
Let's talk about.
no,
Oh, wait.
how about tangent of 17 pi over 12? Let's take a look at this. Right, so again, the first goal is to find two angles that add or subtract to this angle that we have that are on the unit circle, that are values that we know. So, I mean, my personal preference is to convert that to degrees, and I think it's maybe a little bit easier to think about this in terms of degrees, but if you can think about it in terms of radians, that's perfectly fine. Right? But I'm going to convert it to degrees. So 17 pi over 12 is 225.
Sorry, 255.
Yeah, 255. Right. So, we want to think about two angles that we know that would add or subtract to 255. And there's multiple ways that we could do this.
180 and 75.
75 is one of the ones that we know.
I don't know, okay? I don't have the paper like you do.
Right? Does anybody see a way that we could take two values or two angle measures on the unit circle that we know, add or subtract them to get 255?
Wait, so
Don't
on the
ruin
test
it.
for this, are we or are we not going to allow this?
225 is the number.
Probably not. I have emailed the guy at Stark State who teaches it, and I asked him what
I told
he
you.
does.
Oh,
I'm
wait.
waiting to hear back. But
Oh, don't worry, man. I'm sure he'll let us use the.
maybe.
Right, Mr. Cratch, I'm like just as credible as that guy.
Probably. Alright, so Sam suggested that we use 225 and 30. Right? 225 plus 30 would get us 255. So that works. So if we look at our formula for tangents, okay, I'm using the sum formula. So this would split up into tangents of my first one, tangent of 225, plus tangents of 30 over 1 minus tangent of 225 times tangent. Okay, now, when we memorized our unit circle, tangent wasn't one of the values that we memorized, right? But we know that tangent is just equal to sine over cosine. So tangent is equal to sine over cosine. So we can use that idea to calculate each of these exact values. Okay, so we just need tangent of 225 and tangent of 30. Right? Only two values that we need, and then we can plug those in. So tangent of 225 is going to be equal to sine of 225 over cosine of 225. So what is the sine of 225? What is it? Negative square root of 2 over 2. And the cosine? Also negative square root of 2 over 2. Right? So the tangent of 225 is just 1. Tangent of 30 then? The sine of 30 over cosine of 30. So sine of 30 degrees is 1/2. Cosine of 30 is square root of 3 over 2. So whenever I'm dividing fractions, that's the same as multiplying by the reciprocal. So this would be 1/2 times 2 over the square root of 3. 2's cancel. We would get 1 over the square root of 3. But we need to rationalize. So multiplying top and bottom by the square root of 3, we get the square root of 3 over 3. So we can plug those two values in now. So I would have 1 plus the square root of 3 over 3, my numerator, over 1 minus 1 times the square root of 3 over 3. Right, so we're running pretty short on time here. Alright, so we'll finish this one up tomorrow. We'll simplify it. No homework tonight.